Hello everyone and welcome to this session on natural language processing by Intellipaat. Consider these languages such as English, Hindi or French. Humans can easily comprehend these languages, but if the same languages are fed to a machine, will it be able to comprehend them? So this is where natural language processing plays a key role. Natural language processing is a subfield of artificial intelligence that teaches computer to understand and interpret human spoken languages. So in today's session, we'll learn all the concepts related to natural language processing. So before we move further, do subscribe to Intellipaat's YouTube channel and press the bell icon so that you never miss out on our upcoming videos. Also, if you want to become an expert in natural language processing, then Intellipaat provides you an end-to-end certification course on natural language processing. Now let's have a glance at the agenda for today's session. We'll start off by understanding text mining and NLP. Then we'll learn about OS module in Python and file handling. After that, we'll be looking into NLTK package, which is specifically used for natural language processing. Then we'll be going through tokenization, in which we'll learn about regular expression tokenizer and blank line tokenizer. After that, we'll be going through frequency distribution. Further, we'll look into stop words. And finally, we'll learn about bigrams, trigrams and n-grams. Now without any further delay, let's continue with the session.
NLP is a subfield of artificial intelligence where we teach computers how to understand and interpret human spoken languages, or in other words, natural language. So, what in the world is text mining? Well, simply put, extracting information from unstructured textual data is known as text mining. Now, let's say there's a 500-page thesis on some financial topic and you come across a sentence which ends with the number 30. Now, you have absolutely no idea what that number means. It could be the number of days in a month, the amount of dollars a stock increased over the past week, or the number of items sold in a day. So this number 30 could mean anything. And without proper context, you wouldn't get the right information. And this is where text mining comes in. So with the help of text mining, we can give proper context to the words before and after the number 30. And this would help us to find out more information. Now let's look at the need of text mining. So today, with the advent of social media, companies now have access to massive behavioral data of their customers. And most of this data is present in the form of unstructured textual data. But beneath this textual data lies an enriching source of information which can help companies to boost their business. And this is the reason why text mining is being used across various industries. Now, text mining can be divided into 4 practice areas. So we've got information extraction, which basically deals with identification and extraction of relevant facts and relationships from unstructured data. Then we have document classification and clustering, which aims at grouping and categorizing terms, paragraphs or documents using classification and clustering methods. After that, we have information retrieval, which aims at storage and retrieval of text documents. And then we have NLP, which forms the major part of text mining. So here we use different computational tasks to analyze and understand the underlying structure of the text data. Right, now we'll dive into NLP. So when you hear the term natural language processing, the first question to pop into your head would be, what is a natural language? So any language that is used for communication by humans is known as natural language. So English, French, Chinese, all of these are natural languages. Now, since we are humans, we're able to understand these languages. But what about a machine? How is a machine able to comprehend all these human spoken languages? Well, this is where NLP comes in. So natural language processing is a subdomain of artificial intelligence where we understand and interpret human languages using a computer. Now, let's see how is NLP used in text mining. So just think about how much text you see each day. Email, SMS, web pages, the list is just endless. So with the help of NLP, we can go through all of this text data and use it for different purposes such as character recognition, sentiment analysis, and spell checking. Right. Now we'll go ahead and install Anaconda into our systems.
Just a quick info guys, if you are interested in doing an end-to-end certification course in NLP, then Intellipaat provides the natural language processing training course. You can check out the course detail in the description below. Now let's continue with the class.
So Anaconda is basically a free and open source distribution for Python and R programming languages. and it is specifically designed to perform data science and machine learning applications. Right, so these are the 4 steps to work with Anaconda. So first we'd have to download the Anaconda installer, and then we'll install Anaconda. Then we'd have to open Anaconda prompt and update Anaconda. Right, now let me just guide you how we can do this. So first we'd have to go to this website, Anaconda.com distribution download section, and you'd have to download the version for whichever operating system you're using. So if you're using a Windows system, then you'll download Anaconda for Windows. If you're using Mac, then you'll download it for Mac. And if you're using Linux, then you'll download it for Linux. Now, you've got 2 versions of Python. So Python 3.7 and Python 2.7. And we'll be downloading the latest version of Python, which is Python 3.7. So once we download this, we have this setup wizard over here. So we just have to click on next and it'll take care. Now, once the installation is done, we'd have to open up the command prompt. So this is what we get when we open the Anaconda prompt. Now inside this, we'd have to type in conda update Anaconda, and we'll have the latest version of Anaconda in our system. Alright, now let me just go ahead and show how to do it. So I'll just type in download Anaconda. I'll click on this link over here, Anaconda Python R distribution. And over here, I'll click on this download. So I've got different versions over here for Windows, Mac and Linux. And since I'm using a Windows system, I'll download Anaconda for the Windows system. So this is the latest version of Anaconda, Python 3.7. I just have to click on download. Right, so once the download is done, I'll get a setup wizard and I'd have to set it up. And I'll go and click on Anaconda prompt. So this is my Anaconda prompt over here. So now that we've successfully installed Anaconda into our systems, we'll go ahead and work with the OS module. Right. So the OS module, it provides functionalities to perform operating system dependent operations. So these operations include creating directories, creating, renaming and removing files and many other tasks. And these are the different methods we've got. So we've got os.rename, os.open, os.list directory, os.make direct, os.get current working directory and os.fdopen. Now to work with the OS library, we'd have to launch the Jupyter Notebook. So we can either launch the Jupyter Notebook through Anaconda Navigator or we can launch it through the Anaconda prompt. So Anaconda Navigator basically provides you a GUI. So you can either use this or the Anaconda prompt. Now when you open the Anaconda Navigator, you have Jupyter Notebook inside this and all you have to do is click on launch. Now once you do that, you have your Jupyter Notebook right in front of you. So over here, you'd have to click on new and open up a new Python notebook. Now once you do that, you have a new page and over there you'll be performing different operations. So your first task would be to import the OS library. So you'll just type in import OS. Now if you want to have a glance at the current working directory, all you have to do is type in os.get current working directory and it will give you the current working directory. And if you want to create a new folder, then you'll type in os.make dirs and then you will give in the path. After that, you will give in the name of the directory which you want to create. So let's perform this. So again, I'll just type in Anaconda prompt over here. Now inside this, I'll type in Jupyter Notebook. Right. So now we see that we've launched the Jupyter Notebook over here. Now I'll click on new and I'll open up a new Python 3 notebook. So our first task was to import the OS module. So I'll type import OS and I've successfully imported this module. So as I stated in the PPT, the OS module is basically used to work with different operating system applications. So you can create different directories, you can open up new files, you can rename files and so on. So our first task over here is to have a glance at our current working directory. So I'll type in os.getcwd and I'll put in the parenthesis over here. Right, so this is my current working directory, C users Intellipaat. Now I want to make a new directory in my C drive. So this would be the command for that. So I'll type in os.make dirs and over here I'd have to give in the path. So I'll type in C:/ and I'll name the folder as, let's say, new folder. Let me click on run. Right, so now I've successfully created this folder. Now let me actually go to the C drive and see if this folder exists or not. So this is my C drive over here and I see that we have this folder with the name new folder. Now we'll go ahead and perform some more operations. So let's say I want to open a file which is present in my system. So to do that, I've got this command os.open, and inside this I will give in the path of the file and then I'll give the name of the file. After that, I also have to give the extension of file, right? So this is a text file, so I'll type in file.txt. And over here, this is basically the flag. So over here, I'd basically be setting what sort of operation I want to do. So O_RDWR, it stands for read and write. So I've got different operations. So I can open this file in only either read format or write format or read write format. Now, after that, we set in another parameter over here, which is os.o_create. So this means that if a file with the name file.txt doesn't exist, then it'll automatically create this new file and then it'll open it up. And then we've got another operation. So if I want to have a glance at all of the contents which are present in a folder, then for that the command would be os.list_dir and I will give in the path. So over here I want to have a glance at all of the contents which are present in the D drive. So I'll just give in D over here. So these are all of the contents which are present in the D drive. Right, so now I'd want to open this sparta.txt file using the OS module. So let me do that. So the command was os.open, and inside this, as we saw, first we'd have to give in the path. So let me copy the path over here. I'll click on properties. I'll copy all of this and I'll paste it over here. You'd have to keep in mind that you'd have to give in / over here. So the path over here. So to separate all of these, you'd have to give in a /. Again, you'll give in a / over here and then you will give in the name of the file. So the name of the file is sparta.txt. After this, I'll give in the flag over here, which would be os.o_, it'll be read and write. And then I'll give in the pipe operator. So over here, I'll just state if the file doesn't exist, then I'll tell the operating system to create it. So os.create, I'll click on run. Right, so we have successfully opened this file. Now I'd want to have a glance at all of the contents which are present in the C drive. So I'll type in os.list directory, and inside this I'd have to give in the path. So I'd want to have a glance at all of the contents which are present in the C drive. Right, so these are all of the folders or all of the contents which are present inside the C drive. Then I have a couple more commands over here. So this is the command to change the working directory. So over here, I am changing my working directory from D drive to my folder. So I just have to give in the path for this, and this is how I can change the current working directory. And then we can also change the name of a file. So let's say if the name of the file was oldfile.txt, then to rename it, I'll just give in newfile.txt over here. So let's perform both of these operations. So let me perform both of these operations over here. So I'll type in os.chdr. And inside this, I'll set the working directory to just C drive, C://. Right, I've changed the working directory. Now let me also check the current working directory now. Right, so now I've changed the working directory to C drive. Now let me go ahead and rename a file over here. So I'll type in rename. So over here, this takes in two parameters. First is the path where the file is located and the name of the file. So I'd just rename this file over here Sparta. Right, so as we saw earlier, the name of the file was sparta.txt. Let me also remove this over here. Let me just put in a single quotation mark. Now after this, I'd have to rename this. So I'll copy this all again and I'll paste it over here. Now I'll change this to Sparta new. I'll click on run. Right, so now we see that we've got a new file over here. So initially it was sparta.txt. Now we've changed it to Sparta new. Right, so that was the OS module. So the OS module, we saw how can we create new directories and how can we change the names of some files. Now we'll go ahead and do some proper file handling in Python. So the IO module is the default module in Python that is used to perform file handling operations. And it contains functions that return a file object called handle, and this handle is then used to read from a file or write to a file.
Just a quick info guys, if you are interested in doing an end-to-end certification course in NLP, then Intellipaat provides the natural language processing training course. You can check out the course detail in the description below. Now let's continue with the class.
So this is the command to create a file object. So we'll be using this function from the IO module. So open, and this has two parameters. So this is the first parameter file, and over here we'll give in the path of the file or just the name of the file. After that, we've got the mode. So over here, this mode basically specifies the way we want to open a file. So we've got these different modes over here, R, R+, W and W+. So R basically stands for read-only mode, right? So if we open a file in read-only mode, then we can't edit it. So it's only read-only mode and it starts from the beginning of the file. After that, we've got R+, which stands for read and write mode. So over here, the file pointer again starts at the beginning of the file. And with this, we can read the file as well as write something in the file. Then we've got W, which stands for write only mode. And even this, the pointer starts at the beginning of the file and it starts to overwrite the existing file. Then we've got W+, which allows us to write and as well as read. Now this doesn't start from the beginning, but it actually starts at the end of the file, right? So we can start writing from the end of the file over here. So these are the different modes which we can open a file. Now these are the different methods from the IO module with which we can read from a file. So now let's say we've opened up a file. So open, and then I'll give in the path and I'm opening this in read only mode. Now I'll store the file in this F1 instance over here. Now if I want to read the entire file, I'll just type in f1.read over here. So this would give me the entire file over here. Now instead of reading the entire file, let's say if I want to read only the first line over there, then what I'll do is I'll type in read line. So I'm storing this file object in this F1 instance over here. After that, I'll type in f1.readline and this would just give me the first line over here. So let me perform these two operations. Right. So I'll type in import IO over here. Let me load this up. Now I'd have to open the file. So open, I'll take the path. So I want to open up the same file, which is sparta.txt. Right, now I want to open this in read only mode. So I'll type in R over here. Right, so I've also given the board. Now let me click on run. Right, so I've created an instance of this file. Now let me go ahead and read the contents of this file. So I'll type in f1.read. So these are the three lines which are present in this file. This is Sparta, this is 300 and this is Intellipaat. So let me just verify this. I'll open up this file, right? So these are three lines. This is Sparta, this is 300 and this is Intellipaat. Now, as you see, all of these three lines are separated by /n. So over here, /n denotes a new line over here. Now, instead of reading all of these three lines, I want to read only the first line from this file. So the command for this would be os.readline. Right, so now let me click on run. Right, so I've just read one line from this entire file. Now we'll see how to read a file line by line using for loop. So again, first we'd have to open up the file and save this file in an instance. So over here I'm saving this in F1. After that I'll start the for loop. So over here I'll create a new variable. So for line in F1, and this line stores every line which is present in this file over here. So it'll store the first line and then we are printing the first line. Now once that is done, it'll go back and then print the second line, and it'll go back and then print the third line, right? So this is what happens. Now after we print all of the lines, I'm just typing f1.close. So when I type f1.close, it'll just clear all of the buffers and close the file. So I'll just type in for line in f1, and over here I want to print f1, right? So let me start off by using the for loop. So I'll type in for line in f1 and I'd have to print each of the line. So I'll type print line and I'd have to close the buffer. So f1 dot close. Let me close this. Now let me click on run. Right, so let me start off by using the for loop over here. So I'll type in for line in f1. So this is f1 and not s1. I'd have to print each of the lines. So I'll type in print line and then I'd have to close the file. So I'll type in f1 dot close. Right, so let me run this. Right, so I've extracted each of these lines with the help of the for loop. So we've got this is Sparta, this is 300 and this is Intellipaat. Now let's see how can we write something to a file. So to write something to a file, we can use the write method. So again, we'll have to start off by opening the file, but this time we'll be opening this in write mode. So over here, I'll set mode is equal to W, and while writing, I also have to set the encoding type. So the encoding of this file is UTF-8, and what I'll do is I'll add 3 new lines over here. So I'll type in, this is the first line, this is the second line, and this is the third line, and these 3 would be added to this current file. Now, instead of adding one single line, let's say if I wanted to add multiple lines over here. So for this, what I'd have to do is I'll create a list and inside this list I'll separate these three items with the help of /n. So as we already know, this /n, it denotes a new line. Right, now after that we'll open the file, and over here we'll open this in the mode A+. So A+ stands for the append mode, and we'll write this entire list into the file over here. Now let's perform these operations. Right, so what I'll do is I'll copy the same command over here and paste it over here. So the file would be the same, and over here I'll set the mode to be equal to W. So W stands for write, and after this I'd have to set the encoding. So encoding would be equal to UTF-8. So I'll type in UTF-8 over here and I'll click on run. Right, so I've successfully opened this file in write mode. Now I'd have to go ahead and write something into this. So I'll type in f1.write over here, and let me write something inside this. So let me add the first line over here. So the first line would be this is 1. I'll click on run. Then I'll type, let's say, f1.write, and I'll type this is 2. I'll click on run again. Then I'll type f1.write, and I'll add the line this is 3. Now let me go ahead and open the file. So this time I'll open the file in read-only mode. So I'll set this mode to be equal to R, and I'll remove the encoding from over here. I'll click on run. Right, now I'd have to type in f1.read. Right, so this is what I have. This is 1, this is 2, and this is 3. Right, so I've successfully added these 3 elements into my file. Now as you see over here, my file initially had these 3 lines over here. This is Sparta, this is 300, and this is Intellipaat. Now when we use the write mode and we entered these 3 lines, this is 1, this is 2, and this is 3, what it did was it replaced these 3 lines with this. And this happened because the pointer starts at the beginning of the file. And when the pointer starts at the beginning of the file, all that which was there initially, that would be replaced. So let me go to the file now and see how it looks like, right? So I have a single line now. This is 1, this is 2, and this is 3, because the earlier thing was replaced. Now I'll go ahead and actually create a list over here. So I'll name this as L1, and I'll add some values over here. So let's say the first value is A. I'll add a new line after this. Then the second value is B. Again, I'll add a new line after this. And then I'll add a new value, which is C. After that, I'll add a new line. Now I'll open this file in append mode. So this would be the same. The mode would be A+, and I'd have to give the encoding again. So encoding would be UTF-8. Right. So this time I've opened the file in append mode. Now what I'll do is I will go ahead and add this. So f1.write lines, and inside this I'll just put in L1. Now I'll go ahead and open the file. Let's see what do we get. So I'm opening the file in read mode now. Now let me read what we have in this file. So now I have successfully added these 3 characters over here, A, B, and C. So now let me open the file, right? So this was the first line. After that I added A, B, and C. Alright guys, now let's see how can we work with Word document files. So we have this library with the name Python-docx, and we can use this for creating and updating Microsoft Word documents. So to install this library, we'll again have to go to Anaconda prompt, and inside Anaconda prompt we'll given this command, conda install -c conda forge Python-docx. Right, so with the help of this command, we'll be installing Python-docx library. So once the installation is done, we'll go to either Anaconda prompt or Anaconda navigator and then launch the Jupyter notebook. So we'll open a new notebook over here, new Python notebook, and we'll type in import docx. So here you have to keep in mind that when importing the library, you'd have to type docx and not Python-docx. So you'll type in import docx. So once you import the library, now let's see how can we create and update a Word document. So starting off, we'd have to create an instance of our Word document. So to create an instance, we'll invoke the document method. So we'll type in docx.document, and we'll create an instance of the Word document. So I'm naming this instance as document. Now once we have this instance, we can add all of the content into our Word document. So I'll type in document.add heading, and with the help of this I can add a heading to my document. Right, so over here I'm adding the heading. This is a 0 level heading. So here 0 indicates the level of the heading. Right.
Just a quick info guys, If you are interested in doing an end-to-end certification course in NLP, then Intellipaat provides the natural language processing training course. You can check out the course detail in the description below. Now let's continue with the class.
So once we add the heading, now we are going ahead and adding a new paragraph. So here I'm typing document.add paragraph and I'm just writing this is a paragraph. And after that, if I want to add a page break, so we can use this method document.add page break. So we created an instance, and with the help of that instance, we added a heading and we also added a paragraph. Now it's time to save the document. So to save the document, we'll type in document.save, and inside this we'll give in the name by which we want to save the document. So I'm saying the document as document.docx, right? So this is how we can create a document. Now let's see how can we read a Word document. So to read a document, we'd have to start off by importing this document method from docx, and then we'll use this document method, and inside this we'll pass in the name of the document. So we'll pass in document.docx, and this is the file which we had just created earlier, and we'll save this in a new instance and name that to be doc. So once we have this instance over here, we'll use the for loop, and with the help of this for loop, we'll print all of the content inside this document. So I'm typing in for para and doc.paragraphs, print para.text, right? So it'll take in each paragraph over here and it will print each paragraph with the help of this for loop. Right, now let's go to Jupyter Notebook and actually perform this. So I'll start off by importing the library, which is docx. So I'll type in import docx. Now I'll go ahead and create an instance of this. So docx.document, and I'll name the instance as doc. So now that I have the instance, I can add the content into this. So I'll type in doc.add heading. Now let me add the heading. So I'll just say heading 1 over here, and then I'll add a couple of paragraphs. So this time doc.add paragraph, and inside this I'll type in P1, and then I'll add another paragraph. So I'll type in doc.add paragraph again, and I'll add P2 inside this. After this I'll add a page break. So I'll type in doc.add page break, and I'll click on run. Now after the page break, I'll give another heading. So doc.add heading, and I'll give the heading as heading 2. So all of this is done. Now it's time to save this document. So I'd have to type in doc.save, and I'll give the name of the file. So I will save this as, let's say, my doc.docx. Right. So now I have successfully saved this file. Now it's time to read this document which I've just created. So I'd have to import document. So I'll type in from docx. I'd have to import document. Right, so now that I've imported this, so I'll just give in the name of the doc which I've just created. So my doc.docx, and I will store this in a new document again, and I will name this as D1. Right, so now I have created a new instance of the document which I had created earlier. Now I'll use the for loop. So for para in D1 dot paragraphs, and I'll just print this out. So print a para dot text. So now we have the content which is present in the document over here. Heading 1, para 2, and then we added a page break. After that we have the heading 2. Right, so this is how we can work with the docx module. Now let's head on to the natural language toolkit. So NLTK is one of the most widely used packages for the purpose of natural language processing. So NLTK provides multiple packages to perform different operations such as tokenization, POS tagging, named entity recognition, and sentiment analysis. Right? So NLTK provides very easy to work with modules, and with these modules, all of your work becomes much more organized and much more easier. Now again, let's see how can we install the NLTK package. So again, we'll have to go to Anaconda prompt, and we'll give this command inside Anaconda prompt over here. So we'll have to type in conda install -c Anaconda NLTK, and this is how we can install the NLTK package. Right. Now once we install the NLTK library, we have something known as the NLTK Corpora. Now you must be wondering what exactly is a corpora. So before understanding corpora, let's understand what is corpus. So a corpus is a huge collection of written texts, and a compilation of these corpuses is what is called as a corpora. Now NLTK provides this huge corpora for multiple purposes. So it has got all of these different corpuses pertaining to different domains, and we can use it to perform various NLP tasks. Right, now let's see how can we download this NLTK Corpora. So once we install NLTK, we'll have to go to Jupyter Notebook and then type in import NLTK. And then after that, we just have to type in nltk.download. So this would give you a setup wizard. Now all you have to do is click on download, and this will install all of the corpuses which are present in NLTK. So this is how you can import a corpus from NLTK. So there's this corpus with the title names, and we are importing this corpus. So I'll just type in from nltk.corpus import names, and this just has a list of all of different words. So to have a glance at all of those words, I'll type in names.words.
So we'll start by understanding what is tokenization and how we use tokenization to extract different important components from a huge text document. So it is a process of turning a string or a text paragraph into smaller chunks, and those chunks are also called tokens. Tokens can be sentences, they can be words, they can be even phrases or even symbols. When we extract smaller chunks or tokens from a huge text document, that process is called tokenization. We have some useful tokenization methods that we'll discuss here. So the first one that we'll discuss is called sentence tokenization, which we will use to extract all the sentences that are present in a text document. And then we'll move on to understand how can we extract individual words from a huge text document. And then after that, we'll use regular expressions to match patterns in our text document and only extract those words which match that regular expression. And then we have our blank line tokenizer, which will tokenize sentences even if they have spaces or blank lines in between them. It will ignore the blank lines and it will extract the whole sentence. So let's begin with our sentence tokenization. It is used to split a body of text into different sentences. To perform tokenization for sentences, we have to import the sent_tokenize function from the nltk.tokenize subpackage. After importing, we'll generate a sample text that we'll use for tokenization. I've used this text here that Google will shut down its job application tracking system Google had that was launched just 2 years ago. The company had built hire with Diane Green, a former Alphabet board member. This is our sample text, and using this text and using the sentence tokenizer, we'll extract different sentences present in this sample. For doing that, I have initialized a variable called tokenize_text, and I've set it equal to the send tokenize function. So our send tokenize function will take the argument, which is a sample text that we have generated here. So it will first of all extract all the sentences that are present in our sample, and then we have stored all those sentences in the tokenized text variable. So it will be a list of all the sentences that are present in our sample here, and then we can print the list using the print function. So when we print, we'll get all the sentences that are present in our sample text. You can see this is the first sentence that starts from here and it ends here, and the second sentence starts from here and it ends here, and the third one will start from here and end here. So we have 3 sentences present in our sample text. So now let's go to the Jupyter Notebook and we'll implement the sentence tokenization on a sample text. Now let's implement. First of all, I'll import the sentence tokenizer from the NLTK tokenize package. So after importing, I have to run this line. So I'll run this line. So my send tokenizer will be imported from my nltk.tokenize package. So now after that, we'll generate a sample text. I've copied a text from a Google article. So I'll use this text and I'll extract all the sentences that are present in this text. So I'll just copy this and I'll generate a sample variable which will contain this text. So I'll paste my text here. So now we'll use this text to extract all the sentences that are present in this text. So I'll run this line to generate my sample variable. Now my sample text is generated. I will use the send tokenize to tokenize all the sentences that are present in this document. So I'll write sample because my text is stored in the sample document. This is our text document, and I'll pass my text document to send tokenize function. So it will tokenize all the sentences present in the sample, and I'll store the result in send tokens. So when I run this line, all of the sentences will be stored in the send tokens. So now if I want to print the first 5 sentences that are present in the send token, I'll write the line. So it will print the first 5 sentences that are present in the send tokens. So if I want to print the first 5 sentences that are present in the send tokens, so I'll use the following. So if I run this, we'll get the first 5 sentences that are present in our send tokens after the sentence tokenization. First sentence starts from here and it ends here, and this is our second sentence. The apps were removed by Google soon after, and this is our third sentence. So it starts from here and it ends here, and the fourth one is here, and this is our last sentence that we have in our send tokens list. So if I want to know how many sentences are there in my send tokens, I can just use the len function and pass my list, that is send token, and if I press Ctrl Enter, so I'll get there are 9 sentences that are present in this sample text. After this, we'll use Corpora, Gutenberg Corpora from the NLTK corpus, and we'll extract the sentences present in the files that we have in Gutenberg corpus. So if you go to your file explorer and just type %app data, then 1%, and if you execute this one, you'll be redirected to this folder here, and in this folder we have our NLTK data. We have our NLTK Corpora. So once I open this, I'll get all my corpuses that are present in this Corpora, and these are the zipped versions. So these are all corpus that are present in our NLTK Corpora. In this, next we'll use the Gutenberg corpus. So if you look here, we have the Gutenberg corpus, and in the Gutenberg corpus we have several text files. So we have Austin, Emma, and then we have Bible, which is famous for the Gutenberg corpus. So this contains all the text that is present in that Bible KJV. So we have several files, and we'll import these files to Jupyter, and then we'll use different tokenization techniques to extract sentences and words from them. First of all, we have to import the Gutenberg corpus from the NLTK corpus. So we'll write from nltk.corpus import Gutenberg, and after that I will import any one of the file that is present in the Gutenberg corpus. For importing a raw text file that contains all the text, so we have to use the method .ra for the Gutenberg. So I'll write Gutenberg.ra, and then inside the parenthesis we have to mention the name of the file that we want to import. We have a file name called brandstories.txt in the Gutenberg corpus. So we'll import the raw text file. So this file will contain all the raw text, and I'll store it in your sample text, and then we'll use this sample text to tokenize all the sentences using the send tokenize function. And I'll store all my sentences present in this file in tokenized text, and then I have printed sentences from the 5th, so this 6th sentence to the 14th sentence, it will be printed. These are our sentences from 6 to 14. So now let's go to the Jupyter notebook to implement this. We'll start by first of all importing the Gutenberg corpus from the NLTK Corpora. For doing that, I'll write from NLTK corpus import Gutenberg. Once I press Ctrl Enter, my Gutenberg corpus will be imported. Now I want to import a text file from the Gutenberg corpus that we'll use as a sample text for tokenization. So I'll store the text in a variable called sample, and then I'll use the Gutenberg corpus and the raw method of the Gutenberg corpus that will extract all the raw text, all the text that is present in a file. And inside the parentheses, I have to mention the name of the file. The file I'm importing is called Bible KJV. So this will import this raw text file, all the text that is present in this file, and the text will be stored in the sample. So once I run this line, my sample text is generated. So now if I look at the sample text, so you will see we'll have a lot of all the text that is present in our text file. So if I want to extract only sentences from this whole text file, I'll use the send tokenizer extract all the sentences. So I'll store all the sentences in send tokens. Then I'll use the send tokenize function to extract the sentences. And inside the parenthesis, I have to mention the text from which I want to extract all my sentences. So that is our sample. So now when I press Ctrl Enter, all the sentences that are present in this text file will be stored in send tokens. And now if I want to print first 10 sentences from this list here, so I can just write send tokens, and it will print the first 10 sentences that are present in our send token. So this is our first sentence. It starts from here and it ends here, and the second is this one. And similarly we have the first the 10th sentence is this one. So these are the first 10 sentences that are present in this text file. So now the next function that we'll use is word tokenize, that will extract all the individual words present in the whole text. For that I would have to import the word tokenize function from tokenize sub package in the NLTK package, and then I will take a sample text from which I will extract all the words, and then I will use the word tokenize function and I'll pass my sample text, and all these words will be stored in TOK object, TOK variable. So it will be a list of all the words. And now if I want to print the first 20 words, I'll use print this statement, and the first 20 words that are present in this text will be extracted, and they are present in form of a list. And similarly we can use corpus. Here we have used the Genesis corpus that is also present in the NLTK Corpora folder. So if you go to NLTK Corpora folder, you'll find a corpus named Genesis which has a text file named english.kjv.txt. So we have imported first of all the Genesis corpus and the word tokenize function, and we have stored all the text that is present in this file using the .ra method of Genesis corpus, and I have stored all the text in sample. So our sample contains all the text, and then we have used the word tokenize function on this sample, and all the words that are present in this text file will be stored in TOK variable, and then we have printed the first 30 words. The first 30 words you can see in the beginning God created. So all these words are separated and they are stored in form of a list. So let's go to Jupyter Notebook and we'll perform it on a corpus. So we have same corpus, that is Bible KJV. So I'll use this corpus and I'll use the sample text that we have, and I'll extract all the words that are present in this sample. So now first of all I'll import the word tokenize function from the NLTK package. So after I run this line, my word tokenize function will be imported. Now I'll use the sample text and I'll extract all the words that are present in the sample text. So I'll store the words in word tokens list, and I'll set it equal to, use the function word tokenize, and I'll pass my sample that I've created above. Now when I run this line, all the words that are present in the sample text will be stored in word tokens. So after that, if I want to print the first 50 words, I'll just write words tokens. Now if I run this line, first 50 words of the sample text will be extracted and stored in the form of a list. You can see we have this also as a word, as a single token, and this also as a single token. So every single, even if there is a symbol or a punctuation mark, that will also be stored as a token. Now the third function that we'll use for tokenization is regular expression tokenization, which is regx tokenizer. This is the function. So in this function we actually pass a regular expression, and it will match all the words that are present in our text with that regular expression, and it will extract all those words. So for example, first of all we have to import the regx tokenizer from the NLTK tokenize. By running this line, you will import the regular expression tokenizer, and then we have a sample text here which we'll use for extraction, and then we have to define a regular expression which will be used to match every single word that is present in this text document. And according to the regular expression, if the words match the regular expression, those words will be extracted and stored in our cap word tokenizer list. First of all, we have to import the class. So this is a class, regular expression tokenizer. So we have to initialize the class. So this is an object of the class. We have named the object as cap word underscore tokenizer, and in the class arguments, when we initialize the class, we will pass our regular expression. This is the regular expression that we'll use to extract all the words which begin with a capital letter. This is a group of words, so it will search, it will start with a word and it will find any word that lies in this range. So if a word begins with any of these letters that lie in A to Z, so it will take that word, and then slash is an escape character. For W plus means any word after a capital letter. So if there is any word which starts with a capital letter and there is any other word, any other letter after it, so it will pick all those words and it will store in cap word. So now we have to use the .tokenize method of the cap word object to tokenize these sentences, tokenize this text, and we'll write cap word tokenizer .tokenize. Then we'll pass out sample text, and then when we run this line, all those words which match this regular expression will be extracted and will be displayed. So let's go to the Jupyter notebook and extract different words according to a regular expression. First of all, I will start with importing the regular expression tokenizer class from the NLTK tokenize. I'll write from NLTK tokenize. I've imported the regular expression tokenizer class. Now create an object of this class that we'll use for performing regular expression tokenizer. So I'll name the object as regex tokenizer, regex tokens, and then I'll initialize the class. And now I have to, inside the parentheses, I have to mention a regular expression that will be used to match all the words that are present in our text document to extract those words. So I have to write commas, inverted commas, and inside this I'll mention my regular expression. So if I want to match all the words that contain a number, or all the words even if they don't have a number, or all the numbers if I want to extract from my text document, so I'll pass a range, so it will search for all these numbers. Then even if there is a word after the number, it will also extract those tokens. So my regular expression tokenizer will extract all the numbers, and even if there is any word after the number, it will also extract those tokens. So I'll initialize this class. Now we'll use the object instance of this class to extract tokens which match this criteria from our sample that we have used above. So this is our sample, that is viable KJV sample from the Gutenberg corpus. Initialize, I'll use the object that is regex tokens, and there is a method called tokenize. So I'll use the method tokenize, and I'll pass the sample that I have generated above. So once I run this line, you will see all these numbers that are present in our text document are extracted. You can see after the number there is a comma, inverted comma, so that is also extracted. So all these numbers, there is no number which has any word after it, so all these numbers are extracted from our text document using this regular expression. So the next method that we are going to use is called the blank line tokenizer. Blank line tokenizer is used to preserve a sentence even if there is a blank line in the middle of it. So if we have a sentence and in between the words of that sentence there is a new line character which is /n, so that sentence will be preserved and a new line won't be created. So on the background, this function actually uses the regular expression, this regular expression, to match all the tokens. We'll start off by importing the blank line tokenizer class from the NLTK.tokenize. So after importing, we'll create a sample text. This is our text where the text says that good muffins cost $388 in New York, and you can see there is a new line character in between the words, and here also there are new line characters. So once we initialize the class blank line tokenizer, and then we use the tokenize method of this class, and we'll pass our sample text. So once we do that, so our two sentences will be extracted, and you can see the first sentence starts from here and ends here. So it did not treat it as a new sentence. It preserved all the blank lines that are present in the sentence. And the second example is also a sentence where we have, this is the first sentence, so there was a very loud beep is the first sentence, and the next sentence starts from here, and there is a blank new line character in between, and here also there are new line characters. So once we tokenize this using the blank line tokenizer class, so we'll see that we have sentences, but the new line characters or the blank lines are preserved. Now we'll go to Jupyter notebook and we'll implement the blank line tokenizer. First of all, we'll start by importing the blank line tokenizer class from the NLTK.tokenize. Start by importing the blank line tokenizer from the NLTK tokenize package. Once my class is imported, now we can define a sample text which we'll use for blank line tokenization. So I'll write a sample here. So this is my sample. This is the words that we are using. So good muffins cost $3.88, and there is a new line character and there is a space also. So it will preserve these new line characters and spaces as well. So I'll initialize the blank line tokenizer class, and I'll use the tokenize method of this class to tokenize the blank lines and sentences. I'll pass my sample text to this function, and then when I run this, so after importing the blank line tokenizer class, now we'll define a sample text that we'll use for tokenization. So I'll just write sample. I've copied the text, so we'll use the same text to tokenize all the blank spaces or new line characters that are present in the text. So I'll initialize my blank line tokenizer. So I'll firstly run this line to create my sample variable. Now my sample text is created. Now I'll initialize the blank line tokenizer class, and I'll use the dot tokenize method to tokenize the text. So I'll pass my sample text into this function, and so now I'll initialize the blank line tokenizer class, and I'll use the diff tokenize method of that class to tokenize my text. So after that, now I'll initialize my blank line tokenizer class. So I've initialized the class, and then I'll use the tokenize method of this class to tokenize the sample text. So I'll pass the sample text into this method, and then when I run, so I'll get two sentences because this sentence contained a new line character and spaces as well. So it has preserved this whole sentence, two sentences, and then we have the other sentence that is thanks. That is how we use blank line tokenizer to preserve new lines or spaces present in the text. So now after tokenizing the text into sentences and regular expressions or words, now we'll understand what is frequency distribution and how we can leverage frequency distribution. So after performing tokenization using send token, word token and regular expressions, now we'll understand what is frequency distribution and how can we use frequency distribution to get more insights of the text. Frequency distribution is basically, it represents the word frequency in a text. So it will count all the word frequencies and it will display a list of tuples where the first element of the tuple would be the word itself and the next element of the tuple would be the number of occurrences of that word in that text. So we'll use this to gain insights from the data, and we'll see which are the most common words in our text data, and then we can use that information to extract different information from the text, and we can analyze the text further. So for doing that, first of all, we'll import the word tokenize to tokenize the words. That is the first step. And then we are using the Gutenberg corpus from the NLTK corpus as a sample text, and then we have to import the frequency distribution class that contains the functions to perform frequency distribution. So after that, we'll create a sample text which is from the Carol Alice.txt file which is present in the Gutenberg corpus. We'll import the raw text file from this corpus and we'll store it in sample, and after that we'll tokenize all the words. We'll extract all the words that are present in this corpus and we'll store the words in tokenized words. So after we have all the words that are present in this corpus, we'll use the frequency distribution class and we'll pass tokenized words as an argument. So it will count the frequency distribution of every single word and it will store that in fdist. So this is our object that we have created, fdist of this class. So this object contains the information of the word frequencies of all the words present in the text document. So after that, if you want to find which words occur the most in our text document, so we'll use most common method of the fdist object. So we'll write fdist dot most common and 20. So this will print the 20 most common words that occur in the text. So as you can see here, this comma, it occurred 2418 times in the text file, and the occurred 1516 times. So you can see that we have a lot of punctuation marks that don't mean anything. So if you want to extract important words, there's only one important word that you can see here is Alice, which is 394 times. So from here you can actually get the information that this text has something to do with Alice. And we can do the same thing by plotting the frequency distribution. We use the same object, that is fdist. We use the dot plot attribute or dot plot method of this object, and when we write 20, so it will print the 20 most, it will plot the graph for the 20 most common words that occur in the text. Here you can see that the only word that makes sense is Alice. Other words are not as useful. So to implement frequency distribution in Python, we have to import the frequency distribution class from NLTK.probability. And the first step is to create a sample text or a sample document from where we can extract the frequency words and then plot their frequency distribution. Firstly, we'll create a sample, and after creating the sample, we'll tokenize all the words that are present in the sample. And after tokenizing all the words that are present in the sample, we'll create a frequency distribution using the frequency distribution class. So I have imported the word tokenize function from NLTK.tokenize, and then I have imported the Gutenberg corpus from NLTK.corpus, and then we have for the frequency distribution the frequency distribution class from NLTK.probability. And after that, I have imported the raw file, that is carolalice.txt from the Gutenberg corpus, and I have stored the text in sample text. So after creating the sample, now we'll use the word tokenize function to tokenize, to extract all the words that are present in this sample. So for doing that, I have used the word tokenize function and I have passed my sample into it, and it will extract all the words that are present in the sample, and it will store the words in tokenized words. So after we have the list of all the tokenized words, we'll pass our tokenized words to the frequency distribution class, and we'll create an instance of that class that is named here as fdist. So then if we print fdist, it will show us that how many samples exist, or if we just write the fdist, then it will print us all a dictionary which will contain the keys as the words and the value for the keys as the word counts. So let's see how we can implement this in Python using the Jupyter notebook. So we'll start off by importing all the required libraries. First of all, I'll import the word tokenize function to tokenize my words from NLTK.tokenize. Now I'll import the Gutenberg corpus from where I'll pick a text document, text file. After that, now we have to import our frequency distribution class, which we'll be using for creating a frequency distribution of the words. So I have to import it from NLTK.probability. So I'll run all this code to import all the required libraries. Now after importing, I'll create a sample text so that I can tokenize all the words from it. For doing that, I'll store my text in sample, and I'll use the Gutenberg corpus, and I'll use the raw method to import a raw text file which contains all the text present in that file, and I'll use the carolalice. Once I run this line with Control Enter, so my sample, now it will be generated, and all the text that is present in the carolalice file will be stored in the sample variable. So now after we have all the text, now the first step is to tokenize the text, which means to extract all the words present in the text. So I'll use word tokenize for extracting all the words from this text. So I'll store my words in word tokens. I'll use the word tokenize function and I'll pass my sample into it. So once I press Control Enter, now all the words that are present in the sample will be stored in the word tokens. So now if you want to know what is the frequency distribution of every single word that is present in the sample or word tokens. Now we'll use the frequency distribution class. So we'll create an object of this class and let's call it frequency, FREQ. And then now we'll initialize the class. And this class takes one argument, that is of words, all the words that we want to count frequency for. So I'll pass my word tokens into it. Now if I press Ctrl Enter, all the words along with their frequencies will be stored in the FREQ variable or object. So now if I print FREQ, so you will see we get a dictionary. The keys of this dictionary are the individual words that are present in this text document, and the values are the number of word counts. So how many times this word is appearing in this text document, it will be printed as the value for this keys. So our frequency object is FREQ. So now we'll use this object to print the most common words that are present in our text document. We'll add the object name, then we'll use the most common method of this object. And then we can mention how many words we want. So if I want 30 most common words that occur in my document, so I'll add 30, and when I press Ctrl Enter, the 30 words that occur most in my document will be displayed. And out of all these words, you can see the only word that conveys some information to us is Alice. So if we can think of it as this document as it has something to do with Alice. And if we want to plot this frequency distribution instead of printing it, so we can use the plot method of this object. So I'll plot the 30 most common words that are present in the text document. So now you can see and that these are the words that occur in my text document. The is occurring around 1500 times and Alice word is occurring around 400 times.
Just a quick info guys, if you are interested in doing an end-to-end certification course in NLP, then Intellipaat provides the natural language processing training course. You can check out the course detail in the description below. Now let's continue with the class.
Now after frequency distribution, we will understand what are stop words and why we need to remove these words from our text document in order to gain more insights and clear insights from our text data. So stop words are basically the useless words that we have already seen in the frequency distribution that don't convey any information to us. Instead of keeping these words, we'll remove these words. So English has some stop words and these stop words are actually present in the NLTK corpus. If you go to NLTK corpus folder, you will find a corpus named stop words, and in the stop words we have different text files which contain stop words for different languages, 16 languages, and I will import the English version, English stop words. So for importing stop words, we just have to import the stop words from NLTK.corpus, and then we'll store these stop words in stop_words list, and we'll use the set argument. So the set argument will arrange these words in an ascending order starting alphabetically. All the words that are present in the English stop words text file will be stored in stop words, and once we print these stop words, we'll get all these stop words which are like words that occur most of the times in your document and they don't convey any information to us. After importing these stop words, if you want to remove these stop words from our text document, so here's a method that we have used. First of all, I imported the send tokenize and word tokenize functions from NLTK.tokenize. Then I've created a empty list which is called filter words, and then I have imported the Carol Alice text file from the Gutenberg corpus, and I've stored all the text in sample. So now firstly we'll tokenize all the words that are present in the sample using the word tokenize. All the words will be stored in tokenize_word. If we want to remove the stop words from this tokenized words, we can use this code here. We have used a for loop, so it will iterate through every word that is present in tokenized word, and it will check if that word is in stop words or not. So if the word that is present in tokenized word is not in stop words, then it will continue and it will check whether the length of the word is greater than 3 or not. If the length is not equal greater than 3, it will not continue within the loop, and if the length is greater than 3, then it will append that word in the filtered word. So in the filtered word, we'll only have words that are not present in the stop words and all those words which have a length greater than 3 characters. Once we write 3, so it will remove all the punctuation marks as well. This is a handy method to remove punctuation marks. So at the last, we'll get a filtered word list which will contain all the words. So after we have our filtered word list, then if we create a frequency distribution of all the words present in our filtered word using the frequency distribution class, and now we have 2733 samples. So now you can see a lot of words have been removed from this sample. And now if we print the 20 most common words, so now you can see we get a lot of information from the words because the punctuation marks and the stop words were removed. So you can see we have Alice, and we have Queen, then we have King, then we have Turtle, Mark, Hatter, Gryphon. All these words actually convey more information to us than all those words which were before. This is one step in pre-processing, that we have removed all the stop words and all the punctuation marks. And if we plot now the frequency distribution of all the words after removing the stop words, so you can see the word that occurs most of the time is Alice. So now we are pretty sure that this text has something to do with Alice. So this is how we make our machine or computers understand the text using pre-processing. So now let's go to the Jupyter notebook and we'll implement how to remove stop words from a text document. So I'll start by importing the stop words corpus from the NLTK corpus. So my stop words corpus is now imported. So now I will store all these stop words and all the English stop words in a list called stop words, stop_words. So now when I mention the name of my corpus, so I can use the words argument, so it will extract all the words directly from a corpus. So now I have to mention which corpus I want. So I want the English one, so I'll write English, and then I use this set function to arrange these words in a alphabetical order starting from A. So now if I write the set function, if I run this, now my stop words are stored in this list. Now if I print my stop words, so now you can see these are all English stop words that are imported. You can see there is no ones other which we have until. So these words don't convey any useful information to us, so we remove them before performing any text analysis. So after importing stop words, let us import a corpus or a sample text from which we'll remove these stop words. So if I go to my NLTK Corpora folder, and you'll find there is a corpus called Genesis, and in this Genesis we have different text files. So I'll import the English web text file from here. So this is one document in our corpus. There are several documents in a corpus, and once I open this, you can see we have a lot of text here. So now for importing this, first of all I have to import the Genesis corpus from the NLTK corpus. So after importing, I'll import the raw text file, that is English web, from this corpus, and I'll store it in sample variable. So this will import the raw text file, and I'll englishweb.txt. So now my sample, all the text that is present in englishweb.txt will be stored in the sample. So now next step is to tokenize all the words that are present in this sample. For doing that, I'll store the words in word tokens list, and I'll pass my sample in this. So now my word tokens, all the words that are present in the englishweb.txt will be stored in the word tokens. So now there will be stop words and punctuation marks, everything will be present in these words. Now we want to remove the stop words and single line characters as well. So we'll create a new list, that is, we'll call that filtered words, and then we can define which words we want. So we can define it in using for loop in multiple lines, and we can also define it using a single line. So I'll write the single line version here. So it will take all the words that are present in word tokens. Now it will take all the words W here for W in word tokens. So it will iterate through all the words that are present in word tokens, and it will check if the word is not in stop words. So our stop words is this list which contains all our stop words. So if the word that is present in word tokens is not present in stop words, then only it will take those words, and it will also check this condition, which is it will take only the words which have a length of more than 3. and it will store all these words in this filtered word list. So once I run this, I'll get a list filtered words with all the stop words removed and single line and punctuation marks also removed. So now if you want to print the frequency distribution of all the words, so I'll create a frequency distribution. I'll store it in FREQ and I'll use the frequency distribution class, and it takes the words, so our words will be filtered words as an argument. So now my filtered words is created. Frequency distribution of all the words that are present in filtered words is created. So now if I want to know what are the most common words that occur in this whole text, so I'll use the object and I'll use the method called most common, and I'll print the 20 most common words. So you can see these are the 20 most common words. We have Jacob, Yahya, Joseph, Abraham, Pharaoh, Isaac. So you can clearly see it is something related to the Bible. And if you want to plot these words, so we'll just use frequency.plot. So we'll plot the 20 most common words. And here also you can see that the Jacob is occurring most number of times. Then there is Yahya, then is Joseph, and Abraham, Pharaoh. This is how you remove all the stop words. This is a one-liner. So you can remove using multiple lines, or you can use simple one-liner, and it will remove all the words which are called stop words. So after removing the stop words, now we'll move on and understand what are bigrams, trigrams and n-grams. Bigrams are two consecutive words that occur in a text. So if we have a text where our words are in such a way that two words convey more information to us than a single word. So suppose if we have an article about Harry Potter, if we want to know without actually reading the article what it is all about, so if we just tokenize single individual words, so it might not convey the meaningful information to us. So instead, if we tokenize two words at once, so definitely the Harry Potter word will be together. So that is why we use bigrams or trigrams, that will be 3 words, and we can use multiple words 4 and 5 in order to check whether we get more insight from the text data or not. So for implementing bigrams, we'll start by importing the web text corpus in our NLTK Corpora, and we'll also import the stop words. Then we have to import the bigrams function from the NLTK package, and then we'll first of all, if we import a text for the first time, we can also pre-process that text using the wlower function. So if we have Harry Potter, which occurs in the beginning, if there are caps in front of it and there are lower caps or upper caps of the same word, while creating bigrams, those two words will be treated differently. But if we have a same word with lower caps, and that word will be counted as single word. So if we have two words but they are in different caps, so that will be counted as two words. If we lower the words, then they will be counted as a one word. So that is also a pre-processing step for text analysis. So we'll store the text words from the web text corpus. The web text.raw will import the raw text file, all the text that is present in this file. And if you use the words method, so it will import all the words, individual words. But this won't be possible for every text document. It is possible only for corpus. So for other text documents, we have to use tokenization. So if we have imported all the words that are present in pirates.txt file using webtext.words, and it will lower, all the words will be in lowercase. And then if you want to remove the stop words, you can use a single line like this, or you can use the multiple lines. So you will create a empty list. First of all, we'll store all the stop words in stop_words list, and then we'll create an empty list filtered word, and then we'll use the for loop, which will iterate through every single word in our list. It will check if the word is present in the stop word or not, and it will take only the words which have length greater than 3 characters, and all those words will be appended in the filtered word list. So after creating bigrams, after creating the filtered word list, now if we want to create bigrams, we'll use the bigram function and we'll pass our filtered words list, and we'll store this in A. So here A is also a list with 2 words. So if we plot the frequency distribution, first of all, we create a frequency distribution using frequency distribution class, and we'll store it in fdist, and then we'll use the most common at method to print 20 most common words that occur in the text. So you can see here we get the 20 most common words that occur in the text. We have Jack Sparrow, Elizabeth Swann, Davy Jones, Black Pearl, Flying Dutchman. This gives us all the bigrams that are present in our text. So you can clearly see it is something about the Pirates of Caribbean. Before moving to trigrams, let's go to Jupyter Notebook and implement this code. So I'll start by importing the bigrams from the NLTK package. And after that, I'll import a sample text from my web text corpus from the NLTK corpus. I'll import. So now I imported the web text corpus and the bigrams function. So now I'll take all the words that are present in the Pirates document, Pirates text file in our web text. So I'll create a list. I'll directly take the words instead of taking the whole text. So I'll create an empty list. Now I'll store all the words in this list. So I want to keep my words to lowercase, all the words, and it will take all the words that are present in webtext.words. It will take all the words that are present in pirates.txt file in the web text corpus, and if we want to remove the stop words, we can directly write it in one line. We have already created the stop underscore words list above, so we'll use that list. So if you're running this for the first time, so you have to import the stop words and store it in a stop words underscore list, and then you can remove these words from your text document. And we'll mention another condition that take only the words which have length greater than 3 characters. So now if I run this, now all my words which are present in pirates.txt text file and which are not stop words, after removing the stop words, and all the words having length more than 3 characters will be stored in words list. So now if I create a frequency distribution of these words, so if I print, after creating the frequency distribution, if I print the most common 20 words, now you can see we have different 20 most common words, but the Jack is different, Will is different, Sparrow is different, Elizabeth is different. That is why we use bigrams and diagrams to actually gain more insights from the data. Now I'll create bigrams from these words. For doing that, I'll create a list called bigram, and my function is bigrams, and I'll pass all my words into this. So now my bigrams will be created, and now I'll create the frequency distribution for the bigrams. It is bigram, the list name is bigram. So now after creating the frequency distribution, I'll print the most common 20 words, and now you will see we have Jack Sparrow, Will Turner, Elizabeth Swann, Davy Jones, Black Pearl. So this completely changes the information that we get by just using the bigram. Similar to bigrams, we have something called trigrams, which are 3 consecutive words. So we'll check if there are any 3 consecutive words that convey any more information to us. For that, we'll have to import the trigrams function from NLTK package, and I've imported the web text corpus and stop words. So if you're running for the first time, you import these 3, and then I'll import all the words that are present in the grail.txt file, which is in our web text corpus, and I've lowered all the words. So all the lowered words will be stored in text words, and then we'll create a stop words list, and then we'll remove the stop words and store the rest of the words in filtered word. So it will iterate through every word in text words this list, and it will only take the words which are not present in stop words, and the words which have a length of more than 3 characters, and it will append those words in filtered word list. So after that, after creating the word tokens, we'll use the trigrams function to create trigrams. So I'll pass my filtered words list into trigrams, and will store all the trigrams in B. So now I'll create a frequency distribution of B to know which words occur most of the times in my document, and I'll keep it in fdist. Then I'll use the most common method of the fdist to print the 20 most common words. So you can see we have hello, 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 squeak, 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 clop, clop, clop. This grail.txt is about a drama. So in this drama, these all sounds actually present the way a character is introduced, or a character is making some actions. So we have some king, author music, we have clang being dead, we have Arthur king, something related to the Arthur king. Then we have monks chanting, make sure leave. So these are the trigrams that are present in our text document. Now let's go to the Jupyter Studio and implement this. So I'll start with importing the trigrams function from the NLTK package. So after importing the trigrams, now I'll import the grail.txt or the web text corpus. So I have already imported here the web text corpus from the NLTK corpus. So if you go to the NLTK Corpora, and here is a web text corpus, we have 6 documents here, text documents, and each document we can see we have a document called grail. So we have different words here. It is a drama, so there are different characters. So now if I want to import in this one, so if I want to import only the words from this file, so I'll write words, I'll store it in words list, then create a list. So I'll first of all lower all the words using the lower attribute, and then so I'll write the name of the file that I want, so that is grail.txt. So it will extract all the words that are present in the grail.txt file, and then if I want to remove the stop words, I'll just write stop words condition. So I have already created the stop words list, and I'll mention another condition, then take only the words which have a length of more than 3 characters. So now it will create all the words that are present in the grail.txt file, and the words which are not present in stop words, and the words which have a length greater than 3 characters, and it will lower all the words and it will store in this list. So now if we get trigrams from these words. So for creating trigrams, I'll write trigram, function name is trigrams, and it will take the words list as the argument. So when I run this, my trigrams will be created. So if you view the trigrams, this is our trigram object that we have. Now if I want to create a frequency distribution of the trigrams to know which words occur most of the times, which trigrams occur most of the times in my document, so I'll create a frequency object and I'll pass the trigram object that I've created above. So now my frequency distribution will be created. So now let's see what are the 20 most common words that occur in our text document. So I'll write. So you can see we have hello, 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 squeak, squeak, squeak. These are the 3 words, most common words that occur in our document. So we have other words also, but these are the words which occur most of the times. So hello, hello, hello is occurring most of the times in our document, and we can also plot this distribution using the frequency.plot. So we plot the first 20 most common words in this from there. So you can see that hello, hello is occurring most of the times, and there are other words as well. So now similar to trigrams, we have something called n-grams. These are the n continuous words. So if we want to know that if there are more than 3 words that occur in a text that can convey us any meaningful information, so we can use n-grams to extract all those words. So for implementing n-grams, we have to import the n-grams function from the NLTK, and here I've used the Gutenberg corpus and I've imported stop words as well. This is the same line, so it will lower all the words that are present in the Gutenberg.words Shakespeare's Hamlet.txt. So this is a text document in the Gutenberg corpus, and we are importing all the words that are present in this text document, and we are lowering them, and all will be lowercase, and we are storing them in text words. And after that, we are creating a list filtered word, which is an empty list, and it will store all the words which are not in all the words that are present in text words, and those words should not be present in stop words, and the length of the word should be greater than 3. All those words will be appended to our filtered word list. After having the filtered word list, now we can use the n-grams function, and here in the n-grams function we have 2 arguments. So the first argument are the words that we want n-grams from, and the second argument is the number of words that we are searching. So if we are searching for 4 consecutive words, so we'll write 4, and for searching 5 we'll write 5, and we'll store this in B, and then we'll make a frequency distribution, and then we'll make a frequency distribution of the n-grams B, and then we'll print the most common n-grams, most common 20 n-grams that are present in our text document. So you can see we have enter, king, queen, Polonius, Ophelia. This has occurred 2 times. So you can see that our article our text has something to do with King Polonius and Queen Ophelia. So we'll go to a Jupyter notebook and implement this. So I'll start by importing the ngrams function from the NLTK, and then I'll import the Gutenberg corpus from the NLTK Corpora. So now after importing the Gutenberg corpus, I'll extract all the words that are present in. So if we go to our Gutenberg corpus, so this is our Gutenberg corpus. So we'll take this document file, the Shakespeare Caesar, and we'll copy this, the name of the file, and then I'll import all the words from this file, and I'll store this in words list. So I'll lower the words first. The name of the file is Shakespeare Caesar.txt. I'll remove the stop words from this. So if W, and I'll also take only words which have a length of more than 3 characters. So now all my words that are present in the Shakespeare Caesar or text, they are extracted and they are lowercased, and only the words which are not present in the stop words list and the words which have a length of greater than 3 characters are stored in the words list. So now I'll create the ngrams from this list and I'll store it in ngram. So now we have to mention a second argument, which is how many words we want. So let's take 4. So it will take words which have in the sequence of 4 consecutive words together. So now our ngram is created. So now let's create a frequency distribution and print it. So now our frequency distribution is created. Now we'll print 20 or 30 most common words that occur in our Shakespeare Caesar.txt. So this is the 30 most common words that occur in the Shakespeare Caesar.txt file. And we have William Shakespeare, we have Julius Caesar, William Shakespeare, Florius Aurelius, certain commoners. So we have these 4 words which occur in consecutively, 4 words that occur in our text. So these are called the ngrams. So we can mention 5 here, so it will take 5 consecutive words. 6, or if we mention 6, it will take 6 consecutive words. And you can also plot it using the plot argument, plot method. So if I plot the first 20 most common words, so you can see that most common word that is occurring here is beware, radius, march, says, and there are other words as well. So after understanding what are bigrams, trigrams and ngrams, now we'll move on to stemming, and we'll understand what stemming is and why and how we use stemming in text preprocessing for text normalization. Stemming is a process for text normalization which involves the reducing words to their root or base forms. So if we have 2 sentences or more than 2 sentences which contain a word with their derivational affixes, for example, we take a sentence which has the word like and we have another sentence which has the word likely. When we use these words for stemming, they will be trimmed down to their base forms, that is like, and in stemming we don't have any morphological analysis, so you'll find a lot of these words after stemming, they don't actually belong to the dictionary, they don't have a meaning, but still the words which are stemmed, they will have a base form, and then we can use that base form to create words by just adding the derivational affixes, that is ing or ed, the tenses without the tenses. Derivational affixes means tenses here. So to perform stemming, we have a class named Potter Stemmer in NLTK. So we'll import the class Potter Stemmer from NLTK.stem, and then we'll initialize the class and we'll define where an object or an instance of that class, that is PS, and then I've imported send tokenize and word tokenize in case we want to tokenize sentences or words from a text document, and then I've defined some example words. So you can see the word is like, then likely, liking, liked, then unlike, and then when I perform stemming on these words and I print each of the words that is present in example words list. So you'll get the first four words like, likely, liking, and liked. They have the same stem, that is like, and the word unlike has a stem unlike. This last one does not have any vocabulary, but in stemming we don't include vocabulary. If there is any word unlikingly or unliked, it would have the same stem. And we can also perform stemming on a complete sentence. So I've imported the Potter stemmer class from NLTK.stem and have initialized an object, instantiate an object PS, and then this is my example test. So driving a self-driving car might not be fun for a professional driver, but for a lazy driver, a self-driving car saves a lot of driving. When we firstly tokenize the words from this sentence, after tokenizing we'll store the words in words list, and then we'll iterate through the list, and after iterating through the list we'll print the stemmed version of each single word that is present in this list. For driving, you'll see that we have the stemmed version, that is drive, and for this driving we also have the same drive, and then for a professional we have profession, for driver we have same driver, and similarly you can see the other words, so it will be the stemmed version of those words will be printed. Let's implement this in Jupyter Notebook. So for performing stemming, first of all we'll import the Potter stemmer class from the NLTK.stem subpackage. Once we have imported this, now I'll import the word tokenize, so then I can tokenize the words, and then the next step will be to find the stemmed version of those words. So I'll import from NLTK tokenize. So after that, so if you go to on NLTK Corpora, you will find a state union corpus which has different text files, which includes different speeches of different presidents of the United States, so from 1945 till 2006. So we'll take one file from it and we'll tokenize all the words from the file, and then we'll print the stemmed version of different words present in that file. We'll take the 1961 Kennedy file, so we'll copy that file name, then I'll store all the words that are present in this file. So I'll store it in words list. So I'll use the word tokenize function. Then I have to import first of all the state union corpus. Now I've imported the state union corpus. Now from the state union corpus I will import the 1961 Kennedy file. I'll import the raw text file. So for that I'll write this command state union, and I have to import the raw text file. So all the text that I want from this file, I'll write this, and this is a text file. So when I run this, all the words from this file will be stored in the words. So now if we want to print the stemmed version of all those words present in the words list, we'll first of all instantiate a Potter stemmer class object which we'll use for stemming. And the name of the object is PS. Now I have instantiated an object of this class. Now we'll use this object to print the stemmed version of the different words that are present in this words list. So I'll iterate through every word in the words list, and I'll print the stemmed version of these words. If I run this now, it will print the stemmed version of every single word that is present in the words list. So you can see the first word was president, so it has stemmed it to present. So even if it doesn't make sense, still the stemming does not include any vocabulary or morphological analysis, so it will still write present. And for Kennedy, I wrote Kennedy here, and for message it has stemmed the word message to MESSAG. And similarly for president, it has stemmed the word to president. Similarly, you can see there are a lot of words here in this file, and they will have the same words will have the same stemmed version. So after stemming, we have another concept called lemmatization, which is also used for text normalization. In lemmatization, it is a process that involves reducing words to their base forms, but this time we'll use vocabulary and morphological analysis, so that after reducing words to their base forms, they belong to a vocabulary and they have a meaning, and also different morphological analysis will also be performed. So if tenses will be changed, and you will get the base tense of every single word that we lemmatize. So it will bring the context to the words which is not done in stemming. So to perform lemmatization using NLTK, we have a class in NLTK.stem which is WordNet Lemmatizer. So we'll import this class first from NLTK.stem, and then we'll instantiate this class with an object lemmatizer, and then we'll use this object with the method lemmatize, and then we'll pass our text or our strings that we have or our words that we have, and every single word will be lemmatized to its base form. So you can say we have the corpora, which is plural of corpus, so it has been lemmatized to corpus. And then we have cacti, which is a plural of cactus, so it has been lemmatized to cactus. The lions has been lemmatized to lion. And then we have rocks, which is lemmatized to the base form, that is rock. And then we have geese, which is a plural of goose. So every single word has a vocabulary associated with it. And we can also mention the part of speech of that word. So if the word is an adjective, we can write A. The word is a verb, so we can write V. According to the part of speech, those words will be lemmatized. So if we lemmatize the word better, giving the argument that it is an adjective, so it will be converted to good. And if we lemmatize the word best, according to the adjective, it will be still kept as best. And for runs, it will keep run. And for if we mention the part of speech as verb, so it will also keep the same lemmatized version, that is run. So for similar words, we have the same lemmatized and stemmed versions. So now let's go to the Jupyter notebook and implement lemmatization using WordNet Lemmatizer. So we'll start by importing the WordNet Lemmatizer class from NLTK.stem. Once I import this class, now I can use some, first of all, I'll instantiate this class, create an object of this class, so you can use that object to perform a lemmatization. So I've created an object PS. Now I'll define a words list. It can be any words, so I've copied one list. So we have cats, feet, bats, and corpora. So let's see what are the lemmatized version of these words. We have to use the .lemmatize method of this object to lemmatize the words. So we get the cats. For the cats, the lemmatized version will be cat, and for feet it will be foot, and for bats it will be bat, and for corpora it will be corpus. So later on in this course, when we use machine learning algorithms to perform text classification, so we'll use the lemmatization technique to reduce words to their base forms. So when we prepare data for our machine learning algorithms, our data will be in a cleaned form. So this is a pre-processing step that we'll use later on. So after understanding lemmatization, let's move on to the part of speech tagging, which is actually used for categorizing words into their grammatical groups. So in part of speech tagging, the task is to label each word in a document, in a text document, with its grammatical group. So we'll label a word if it is a noun or a pronoun or a verb or an adjective or an adverb. So we'll use this for categorizing and understanding the syntax of different words that are present in our text document. So these are some of the tags that will be attached to our words that are present in our text. The word has a tag as CC, so it means it is a coordinating conjunction, and if it has a tag of NNP, it means it is a proper noun, singular. And then for JJ, it is adjective. And for there are a lot of other parts of speech, so for those there will be a different tag attached to every single word in the text document. So let's see how we'll use part of speech tagging using the NLTK package. So here I have imported NLTK package, and then I have imported the word tokenize to tokenize all the words present in the text document. So this is our text document. So I have stored it in sample text. So the Google has actively been purging malware-laden apps from Play Store. And this is our text document. Now the first step is always to tokenize the words. So I'll perform the word tokenize on this sample text, and I'll store all the words from this text in tokenized text. So when I print this, you'll see that all the words that are present in this whole text document are displayed. And the next step now is the part of speech tagging. So we have a function called POS tag in NLTK. So once you import NLTK, then we can use this function. So I'll write NLTK.POS underscore tag, and then I'll pass the words that are present in the text document. So my words are stored in tokenized text. So I'll pass my words in tokenized in NLTK.part-of-speech tagging. So every word that is present there will have a label attached to it. So you can see the Google has been classified as a personal pronoun, and has is a verb, past form of verb, and RB is adverb, and VB is also a verb, and malware laden, so this is classified as tagged as an adjective, and apps has been tagged as noun, and from is tagged as interjection, and the is tagged as DT. So those are called determinants. So DT is determinant, and similarly we have for every single word that is present in our text, tag has been attached, and it is returned as a list of tuples. The first element of the tuple is our word, and the second is the part of speech tag. So now let's go to the Jupyter notebook and implement on this part of speech tagging on a corpus. So I'll start off by importing the POS tag function from the NLTK package. So I'll let once my function is imported, now let's go to the state of the union addresses. So we'll take the 1996 Clinton address. So we'll take this file, take this document, and we'll import all the words, tokenize all the words present in this document, and then we'll attach a part of speech tag to each word present in this document. First, let us extract all the words using word tokenization. So I have already imported the state union corpus. So I'll import the raw text file, and we have the 1996 Clinton text. So all my words will now be stored in words. So now let's print the POS tags of each single word that is present in words. So once I run this, so I have all the words along with I have a list of tuples, and the first element of the tuple is the word itself, and the next element is the POS tag associated with that word. So the president has been classified as a personal, as a proper noun, and then we have interjection before is tagged as interjunction, and we have most of the personal proper nouns, and there is a preposition you. So for every single word there will be a tag attached to it. So later on we'll use these tags to understand the syntactical structure of sentences, and how we form sentences, and how we make computers understand how to make sentences. So we have used the part of speech tagging to tag different parts of speech that are present in our text. So after that, we'll use named entity recognition to identify different entities present in our text. So if there are any people, places, organizations, or locations that are present in our text, so we'll use the named entity recognition to identify those words. So named entity recognition is used to identify important named entities in text, such as people, places, organizations, location, even dates, so work of art. So these are different tags that our named entity recognition will assign to all the words that fall in this category. So if there is an organization, so it will be tagged with organization, and then we have location, so any particular location will be tagged with location. Then we have geopolitical entity, which is any country or a state or a province, and we have date, time, person, so any person will be tagged with the named entity as person. So to perform named entity recognition, we have to use the NE-chunk function that we'll use. So first of all, we will import the 2005 George W. Bush State of the Union address from the State Union corpus. I have imported the word tokenize and the State Union corpus, and I've imported the raw text file from that is 2005 George W. Bush address, and then I've tokenized all the words from this text file, and these are all the words that are present in this text file. So the next step in named entity recognition after tokenization is attaching a part of speech tag. Once we attach a part of speech tag using the POS tag function from the NLTK, so we'll pass our tokenized words to an POS tag function, and then it will attach a part of speech tag to every single word that is present in the tokenized text list, and that will store the result in POS words. So after that, to perform named entity recognition using NLTK, we will import the NE-chunk named entity chunk function from the NLTK, which will chunk all the named entities present in our text. So we'll first of all import, and then we'll store the named entities in NAR words. So use the function NE_chunk, and we'll pass the part of speech tags. So this will be the words along with their part of speech tags, and then all those words which belong to any category of named entities, all the named entities will be assigned a category according to these rules, these categories. Once we have processed this, we'll store the result in any words. So when I print any words, you can see that George has been classified as a person, and address has been classified as an organization, and joint is also tagged as an organization, and we have Congress as an organization. So a lot of times you will find that wrong classification also. So it is still improving. For some words it will have the correct tags, for some words it won't have the correct tags. So now let's go to the Jupyter notebook and implement named entity recognition on a corpus. So this is our NLTK Corpora, and we are in Gutenberg corpus. So I'll take this document as word parents from here to extract words, and then find all the named entities that are present in this text. So I'll start by importing the Gutenberg corpus. So after importing the Gutenberg corpus, I'll extract all the words and then assign a part of speech tag. So I'll store it in part of speech words, and then first of all I'll tokenize all the words, and I want from the Gutenberg corpus the raw file, which is edgeworthparents.txt. so all the words from this file will be tokenized, and then I want to add a part of speech tag to every single word. So I'll wrap this whole thing in part of speech POS tag function. This function will extract all the words that are present in this file, and it will tokenize, and then it will attach a part of speech tag, and we'll store this in POS words list. So once I run this, my part of speech tags will be associated. Now if I want to find all the named entities present in these words, so I'll import the NE-chunk function from NLTK. I'll import the NE-chunk function, which is named entity chunk. So I'll use this function to extract all the named entities present in this word, these files. So you can see if I print the length of my POS words, so there are around 2,09,120 words. So it will take a lot of time to process all these words and find named entities. So I'll take the first 2,000 words and find all the named entities present in that. So for that I'll store my named entity words in NER words, and then I will use the NE-chunk function to chunk all, or to find all the named entities. So I'll pass here my POS words after attaching part of speech, and if I want only the first 1,000 words, so it will chunk all the first 1,000 words, and then we'll print all the named words along with their named entity tags. So you can see that first 1,000 words, it has attached a tag of organization to parent, and organization to assistant, and then person to Maria, organization to the, and then Rosemary is also classified as geopolitical entity, any place, and then we have Ireland, which is also tagged as a geopolitical entity. So these are all part of speech tags, which is a proper noun, and this is our named entity recognition NER tag, which is geopolitical entity. So after learning about different pre-processing techniques such as tokenization, lemmatization, stop words removal, part of speech tagging, and named entity recognition, now we'll move on and we'll implement all of those concepts using a more advanced package called spaCy. spaCy is a free and open source library, and it is extensively used for natural language processing. It is written in Python language, which is C extension of Python, and that is why it gives us performance like C in Python. It is fast, and it provides us concise application programming interfaces to access its methods and properties. So we can perform all of the operations that we have performed with NLTK using spaCy, and you will see that how easy it is to perform such operations using spaCy. So we can perform tokenization, lemmatization, part of speech tagging, dependency parsing, named entity recognition, and some other concepts such as sentence boundary detection, similarity, and text classification. Before using Spacy, we have to install it. For installing Spacy in Anaconda, you have to go to your Anaconda folder in the start menu, and you have to open the Anaconda prompt. After opening the Anaconda prompt, you have to run the following code, and once you press enter, so you'll be asked to proceed with Y or N. So just type Y and press enter. So once your Spacy is installed, now you have to install Spacy model. So Spacy has different models in different languages. So these models contain vocabularies, pre-trained vectors, syntaxes. We can train our own models, but for these tutorials, we'll use a pre-trained model, which is the English model. So for downloading the English model, you have to run the following code in the Jupyter. You have to run the following code. For downloading the model, you have to run the following code in the Anaconda prompt. So your model will be downloaded. So after these two steps, we are ready to work with the Spacy module. So our first step is to perform tokenization with Spacy. So we'll see how to perform tokenization. So the first step would be to import the Spacy package. And once you import the Spacy package, the next step is to load the model that you want to use. So we have downloaded the model, that is NCore Web English core model. So we'll load it using spacy.load. After loading the package, we'll store it in the NLP object. So now we'll use this object to perform different functions like tokenization, lemmatization. So firstly, we'll create using this object pre-processed variable or another object. Once we create a Spacy object, then the next step is to pass the string or the text that we want to pre-process. So once you write NLP, which is this object, and then you pass your text document inside of it. Once you pass, so the Spacy model will automatically pre-process this text, and it will extract all the entities, and it will perform lemmatization and named entity recognition. Once we create a processed object, we'll store it in doc. Once our processed object is created, the next step is we just have to see how to print different tokens or lemmas or named entities. To perform tokenization, we just have to write token.txt. So the tokens are stored in .text attributor for this document. To print all the tokens that are present in our text document, we'll just use a for loop to iterate through all the tokens. So we have written for token in doc. Doc is the processed object of Spacy model, and then we'll iterate through every single entity that is present in every single token that is present in our doc. For that, we have written for token in doc print token.txt. So this .text is the token that we want to print. We will see that all the word tokens that are present in our text document are printed. So the next step that we'll perform is a lemmatization with Spacy. We'll create another processed object. So we will use the NLP object that we have created using the spacy.load, and we pass our text document into it, and then we'll store it in doc. And after creating this processed object to print lemmas, we just have to iterate through the lemma.text and .lemma. So the lemmas are stored in .lemma underscore method of our document. So we'll iterate through every lemma. So we'll print the text, which is the actual word token, and we'll print along with the lemmatized version of those words. We'll iterate through using for loop. For lemma and doc, we'll print lemma.text. So this will print the token, which is Google, and the next it will print lemma.lemma underscore. So it will print the lemmatized version of those tokens. So you can see these are the second words are the lemmatized versions. So our locations is changed to location, and uploading is changed to upload. Images is changed to image, and here we have some scary. Deemed is changed to deem. Scariest is changed to scary. The scary is the lemmatized version, and creepy is also the lemmatized version, and include is also the lemmatized version. How easy it is to perform lemmatization with Spacy? You just have to load a document and use the .lemma underscore argument to print the lemmas that are present in our document. So the next step is to perform part of speech tagging with Spacy. We have already loaded the same document, which is this one. So it is stored in doc. So to print all the part of speech tags, we'll just iterate through all the tokens present in the doc. For printing the token, we use token.txt, and then I have added this 3 lines here. And then for part of speech tag, we have to use .pos underscore attribute or method. So it will print the part of speech associated with that token. And if you want to know the part of speech just as a tag, so we'll write .tag underscore. So it will print the spacey version, and this is the NLTK version. So our Google is tagged as a proper noun, NNP, and maps is also a proper noun. And then we have similarly verbs, nouns, interjection, determinant, verbs, determinants. This is the preposition. This is how we perform part of speech tagging using spacey. So we have to use .pos underscore method of document, and to print the text we use the .tag underscore method. So spacey also provides us different visualizers to visualize these part of speech tags. That package that we need to visualize is called displacy. So we'll import displacy from the spacey, and this is our model that we are using, that is English model. And then we load an object of this model and we pass a string. When we pass a string, we'll get a processed object which we have stored in doc. So to visualize this, we have to use displacy.render. So this is a function that we'll use in the Jupyter notebook. Once you write displacy.render, so we have to pass the document that we have processed, and then the style argument will tell us which style we want. Here it is DEP, which is called dependency passing. So it will print the words, or will print this image where it will show which words depend on each other. Is our root verb here, which is a verb, and once you run this line, you will get this graph here. So our is a root word, and is depends on processing, and processing depends on language, and then language depends on natural. This is also tagged as a proper noun, and this is also a proper noun, and or is a verb. So our root word is, and then we have an attribute called fun, and our subject is processing. So these are two dependent tags that depend on processing, and this all of this depends on its. Next, we'll see how we perform named entity recognition with spacey. We'll load the spacey model, and then we create a pre-processed object using the model's object. So once we pass our text document in this, we'll store the process object in doc, and then to print named entities, we have to use .ents method of our document. So for printing all the named entities, we have used the for loop to iterate through every single entity. We'll use for int dog.ents, and we'll print entity.text. So it will print the text of that entity, and then to print the label of which tag is associated, which entity is associated with which tag or which category. For that, we'll use ent.label underscore. So this text is our entity. This is the label that is associated, or the class or the category which it has been classified. So our Tokyo in this text has been classified as a geopolitical entity, which is country or a city. And then we have more than 38 million. So it is tagged as a cardinal. So it means cardinal is number. And we have Japanese, so it is classified as NORP. So that is nationalities or religious or political groups. And then we have a same geopolitical entity, that is Osaka, which is also a city. And then we have 20.5 million, which is classified as a number. So a numerical entity. We can also use visualizers using the displacy method for named entity recognition. So this is the same text that we used before. So this is our text document which we have passed to the NLP object, and then it will be processed and will be stored in doc. So we'll use displacy.render. So we'll pass our document here. Yes, and now we want style to be ENT, means it will show all the named entities that are present in our text. Once you run this code, you will get this graph here. So every named entity will be separated with a color and along with its label. So now let's go to the Jupyter notebook and implement all of these concepts using spacey. So I'll start by installing spacey first of all. So I have pasted this code here, conda install conda for spacey. So once I run this code, my spacey will start downloading. Now you have to press Y to proceed. So you enter Y and press enter. So now your spacey libraries and other packages will be installed. It is 91.9 MB. So it will take some time to install. So once it is installed, then we'll move on to install our English core model. So once your Spacey is downloaded, now you can move on and download the English module using the following, just using this code here. Now it will download our English module. Now our Spacey and our model, English model, both are downloaded. Now let's go to the Jupyter notebook and start working with Spacey. So we'll begin by importing first of all the Spacey package. So after importing the Spacey package, now we'll load our English model. So I'll create an object called sp and load my English model using spacey.load, and the name of our English model is n. Now our English model is loaded. Now we'll create preprocessed object in which we'll pass our text document. I'll store it in doc and we'll use our object sp, and inside of this we have to pass our text. So I've copied this text where Google on Friday celebrated its 21st birthday. So this is our text. So we'll start by tokenization. So we'll first of all find all the word tokens present in this text. For that, we'll iterate through all the word tokens. Word tokens are stored in .text method. So when I press enter, you'll see we'll get all the word tokens present in our text document. Now after this, we'll print all the lemmatized versions of these words present in the text document. So for that, we just have to use another for loop. So it will print the original word, and then if you want to print the lemmatized version of those words, we have to use the method lemma underscore. Once I run this, you will see we have the original words and the lemmatized version. So we have for celebrated, it is celebrate, and for showcases it has showcase, and for biggest it is big, companies it is company. So these are all the lemmatized versions of the words present in our document. After lemmatization, let's implement the part of speech tagging, and we'll print the part of speech, the words along with their part of speech tags. So for that, we'll just use another for loop. So if I run this now, we'll get every single word along with the part of speech and then the tag associated with that part of speech. So our Google is a proper noun here, NLP, and similarly for every single word present in our text document, we have a part of speech label and a part of speech tag. Now we can make using displacey, we'll make a dependency tree. So first of all, we'll import our displacey package from Spacey. So after importing displacey, we'll use the displacey.render function to print our part of speech tags as a dependency tree. Side of this function, we have to pass our document, that our processed Spacey document, that is doc, and then we have to mention what type of plot or graph we want. So we want here dependency passing using the part of speech tag. So we'll write style. For dependency passing, it is DEP. So once you run this, you will get all the words along with their part of speech category and the dependency parse tree or the parse object. It will show us which words depend on each other and which is the determinant, which is the compound noun and subject. So we can all see it through this graph. This was about our part of speech tagging. Now let's see how we can perform named entity recognition on the same text that we have mentioned above using Spacey. So you just have to use another for loop. So for named entities are stored in .ents method of our document. So this will iterate through all the entities present in our document. Print. So here you can see that among all the entities, our Spacey has recognized these, and from all the words it has recognized these entities. So our Google has been identified as an organization Friday is a date, 21st is ordinal, so it is a number, and Google is also organization, and this is September 27, 1998 is a date, and Larry Page and Sergey Brin are identified as persons. Now let's use the visualizer using DisplayC for making a plot, making a graph that will represent all the named entities present in the document. So I've already imported this DisplayC package, so now we'll just use DisplayC.render. So in this we'll pass our process object process document, that is DOC, and then the style will be now equal to ent, which will print all the named entities present in the document. Once I run this, we'll get all the named entities along with their labels that are present in our text document.
Just a quick info guys, if you are interested in doing an end-to-end certification course in NLP, then Intellipaat provides the natural language processing training course. You can check out the course detail in the description below. Now this brings us to the end of this session. If you have any query, do comment below and we would love to help you out. Thank you.